Okay, so now we're going to look at some guided practice problems.
All right. We're talking about
Okay.
dilutions.
All right.
Dilutions are used for, like, if I have, if I made some lemonade that's like just way too strong.
Mm-hmm.
Like, what could I do to make it taste better?
Add some water.
Yeah, that's right. I'm diluting it, right?
Right.
I'm spreading the flavor out a little bit more.
Okay. All right.
So that's what we're doing here. These are dilutions. The
Okay.
M stands for molarity.
Okay.
Right?
M stands for molarity. I see I've got an M1 and an M2.
Yes. So you're going to have an initial concentration. That's your M1.
Uh-huh.
Right? M1 is initial.
Right.
And then your M2 would be your final.
Okay.
Yeah.
All right.
Same goes for your volume. Your V1 is your initial volume, and your
Okay.
V2 is your final volume.
Right. That makes sense.
Yeah, and the good news is we don't have to convert these to liters.
Oh.
The volumes. The volumes can stay in milliliters.
Oh. That makes life easier.
That makes things so much easier,
okay.
right?
So let's take a look at that first problem.
So we got one volume in milliliters.
Milliliters.
What volume in milliliters of water would have to be added to 150 milliliters of 0.45 molar potassium chloride, KCl, to give a solution with a concentration of 0.100 molarity.
Okay, so I only see 1 milliliters in there, so I know that's going to be my volume, and I think that's my starting volume, right?
Yeah, that's right. It's the first one they give you.
Right.
They're saying that initially we had a volume of 150 milliliters, right?
Okay.
And initially the concentration is 0.45 molarity.
Okay.
Let's see. And we want to have a concentration of 0.100,
right.
so that's my M2. And what are they asking for in this problem?
How much water has to be added to it?
Okay,
so
that's
we're gonna,
kind of tricky, huh?
Right, that is a little tricky. We can solve for V2, but that's not how much is added to it. So we're gonna have to do another step there, aren't we?
Right. Yeah. So it's kind of a two-step problem.
All right.
We're going to find our V2
start
first.
Finding our V2.
Mm-hmm.
All right. So
once we got our knowns, just plug everything in, right?
All right. Yeah. Let's plug everything in the formula.
So we got our formula up here. That's M1V1 is equal to M2V2. So I'm going to plug in my M1, 0.45, times 100. Oops, I was putting a 0 there. 150 milliliters.
Yeah.
Is equal to my M2. That's 0.100 times V2.
Okay. So to solve this, I'm just going to multiply those two numbers, 0.45.
Yep. Solve this part right here first.
Times, that's 50, right? Wait.
It's 150.
150.
Yeah. That's my bad.
Okay. And then I'm going to divide that by
0.100. We're going to divide both sides by 0.100.
Oh, okay. All right. And we get 675.
There we go. So V2, our final volume, is 675 milliliters. So the key there is that, like, this is our final volume, so that's what it was changed to.
Okay.
So we can subtract those two and find out how much was added.
So that means I added 525 milliliters.
Yep.
Okay.
There we go.
All right. Let's take a look at this next example.
All right. What is the new molarity if 250 milliliters of 0.500 molar NaOH is diluted to 1.5 liters? Okay, so in this case, we are going to have to do a conversion because we want that liters and milliliters.
You lied to me. You said no more conversions.
I know, you're right.
Okay, well, let's start by writing our
conversions, right?
Yeah. Let's see. We've got 250 milliliters. Let's start there.
Yeah. So that's our V1.
That's our V1.
And then our M1 right there.
Right.
That's what it was initially, the initial concentration.
Initial molarity. And then we diluted it We added more water to make it 1.5 liters, so we need to make
Right.
that into milliliters, right?
So we got to move the decimal place because we're going from liters
Right.
to milliliters.
So we just move it to the right 3 places, right?
Right.
Okay.
So we're going to go
So-
1, 2, 3. So that should be 1, 5, 0, 0
milliliters.
milliliters. There we go.
Okay.
And we're trying to find M2.
All right. We could have done it the other way around where we converted both into liters, but I like the bigger numbers better.
Yeah.
Okay. So, now we just plug into the formula, right?
Yep, that's it.
Okay. So we've got
250
50
times
times
0.500. So we got both of our initials,
Okay.
our V1 and our M1 on the same side. And then the V2 will go over here, times M2.
Okay, so when I multiply 250 times 0.5, I get 125.
Is equal to 1500 times M2. So then we divide both sides by 1500. Cancels out.
Okay, and we get 0.083.
Molar, oh, is there M2?
M2.
There we go.
Okay,
Well, that wasn't hard.
that was not hard
Even
at
with a
all.
little bit of conversions.
Okay, let's look at this next one.
Very last one.
All right.
It says, what volume in milliliters of water must be added to 12.5 milliliters of concentrated HCl, it's 12 molar, to make a 0.25 molar solution.
Okay.
So again, it's another one of those, like, we find the V2, but that's not quite the answer yet. You know.
Okay.
So we got our V1, that's 12.5
Right.
milliliters. And our M1, the initial concentration is right there, 12.0 molar. There we go.
molarity.
To make a 0.25 molar. So this M2, that's what it was changed to. And then we're trying to find V2 so that we can find out how much was added to make that. Right. So we just plug everything in. All of our initial numbers go on the same side. So 12 times 12.5 is equal to 0.250 times V2. And that's 150 when we do 12 times 12.5. And then divide both sides by 0.250.
And we get 600 if we do that.
All right, so 600 milliliters is our V2, all right? So that's what it was changed to.
Right, so that's how much volume it's taking up now.
But
But I want to know how much I had to add. So,
Yep.
so we subtract.
So we 600, our V2 minus our V1, right? And that gives us
587.5
all right.
milliliters.
That's how much we had to add to get to 600.
All right.
Cool.
Great.
All right. And as always, ask your teacher if you need any help.